Today we are going to start a new topic, that is command query responsibility segregations, that is CQRS architecture in our backend architecture series. Earlier we have studied monolithic application, microservices application, and event driven architecture, and now we are studying the CQRS architecture. So in CQRS architecture, first we have to understand what is traditional CRUD model. So in traditional CRUD model, you have to communicate with your backend database, backend server or database using APIs. So these APIs are create API, read API, uh, update, delete. There are various methods that you use to communicate with your database or backend server. Then when your request hit the backend server, then the backend server communicate with the database. Then database perform the updation and return the response to you. Then the response is sent to the front end, and user receives the data. In this way the traditional CRUD model works. So now we have to understand how the CQRS works, and how the CQRS is different from other architectures and traditional CRUD model. Now, let us understand the working of CQRS first. So here, the CQRS is divided into two sides, that is command side and query side. So now, in command side, First, first you have to first the user send the request to the command side. Then command side process that request, validate with the business logic, and then this command side will trigger a event. Here, command side and query side simply means that command side means uh, here command side means make a change. Command means make a change, and query means I want to read something. So command means change or update, and query means read. So now returning back to our CQRS model, here command side means I want to update something. For example, if I am updating my profile photo, so my request for updation of my profile photo will go to command side. Then command side will process that request and apply the business logic, and then that request will and that event is get triggered. Okay, here the best part is this architecture works good with event driven architecture. So here after every updation we release a event. Then this event is continuously listened by the query side continuously listen to this event. Then when receiving after receiving this event, query side perform updation in their server. Then whenever I want to view my profile photo, then my request will go to query side. My request will go to query side, and I will get my response back fast. So the best part here is the two things, that is I want to update, delete something, is separated from I want to read something. There, the application is divided into two parts. So by using this technique, we can improve our application drastically. We can improve our application. So this is the basic flow. This is how basically in the higher abstraction way the whole architecture works. So I told you all the working in a higher abstraction, but the real working is a little bit complex. Now let's see about the features of this architecture. So first feature is independent scaling. Independent scaling means the command side and query side are separated, and if the numbers of users are increased on command side, you can increase the number of servers of command side. You can increase the number of servers of command side vertically, horizontally. Horizontally means you are increasing the numbers of servers, and vertically means you are increasing the CPU, or you are increasing the RAM. So this means the independent scaling. And if your application is receiving frequent users for query side, then you can simply increase the number of query side or query server. So the next feature is optimized query model. So you can optimize your query model here. Your query model, you can use various technique like caching, and you can use Apache Expresso, Waldomart, just like LinkedIn did in their application. They used CQRS model and they implemented Apache Expresso and Voldemort in their query side, and it gives them better results. Then the next thing is manageability increases. So the two sides of the application are separated. So you can manage command side separately, you can manage query side separately. And if there is any problem in command side, you just have to make the changes in command side. You don't have to update the query side. That's the best part. uh, the next part is supports event sourcing. Event sourcing is a good part, that if your object in traditional applications, if your object is changed, then you just save your last state in the database. The state in which object is in the last state, you save that state in the database. But in CQRS model, your object data is stored through every event, through the series of event that object went through. All the data of the events is stored in your database. That's the best part. Then the next thing is, okay, we have covered the features. Now we will see when when to use this architecture. So when to use, when you have a complex business logic, when you have to when you have a complex business logic, then you don't have to use CQRS model. Then you don't have to use CQRS model because it will increase your complexity again. Okay. Then if your application is getting frequent reads, if your application is getting frequent writes, then you surely choose CQRS model. If you can handle the complexity of your application, then you have to choose it. The next thing is, if you want to optimize your read, if you want to highly optimize your reads, and if your application is getting higher number of requests, your number of requests for read operations are highly outnumbering the number of requests of your write operations, then you can surely go with CQRS model. The next thing is, uh, when you have to avoid this thing. Okay, when you have to avoid this architecture, when your application is simple. If your application is simple, then you don't need to manage two servers separately. You don't have to segregate your business logic. So in read and write part, and if and the next thing is, if you don't want complexity, because segregating two parts of your application will bring a sudden complexity in your application, because now you have to manage your command side, now you have to manage your query side, then again you have to optimize them as well. This architecture brings complexity, but it also brings optimization as well to your application. The next thing is, when you should use this architecture, with when you want the event driven, when you are using already using event driven architecture, then you can implement the segregation of query and command side, and then you will achieve the higher optimization of your application. So the next thing is, uh, LinkedIn. We will take an example of LinkedIn. LinkedIn increased their optimization of their application using Apache Expresso and Voldemort. It's basically a database, key value database, that returns the read that returns the value, or it basically optimized their query side, that is read part. LinkedIn highly optimized their query side using this Apache Express and Voldemort for faster reads. Then LinkedIn. Now you will never say that my LinkedIn application is lagging, my LinkedIn application is slow, because their query side is highly optimized. They segregated their command side, their, it means their updation logic, and their read operations. It means that query side they completely segregated their architecture, and they highly optimized. Not only this, they highly optimized the query side for faster reads. It means if you want to see someone comments, if you want to see anyone's likes, you instantly get it because their query side is highly optimized. So in this way, I have explained you the features, I have explained you when you should use this architecture, I have explained you the working of this architecture, like how the event release, how the command side works. It release the event, query side listens to that event, query side updates itself. Basically, you should use this model when you want the updation in your application. I have again explained you what is traditional CRUD model. This model we use in monolithic applications mostly. And then Okay, so I've finished everything. I've shared what I know till now to you guys. So thank you for watching my video.